Wait a minute, this isn't good. This isn't good. What if maybe if I... Oh. No, that's not right. Hold on.
Consider this thought experiment.
There we go. Let's take this from...
Since the beginning of recorded history, humans have been tracking time. Whether it be the rudimentary calendars carved into stone tablets or the sundials dotting Roman cities, we've been using time to define events along a linear line, because time is always constant. Right? I mean, that's what everybody knows to be true, isn't it? Consider this thought experiment. There are two identical men. The first is standing alongside a train track. The second is on said train traveling along said track at the speed of light. At the exact moment that their positions overlap, lightning strikes in two places equidistant from both men. The light from the combined flashes reaches the first man at the same time. Thus he concludes that the strikes were synchronous. The light from the two flashes reached the second man at different times due to the speed he's traveling. Thus the second man concludes that the strikes were asynchronous. Both of the men observed the same event, yet had vastly different conclusions. Why is this? First, start with the postulate that the speed of light is a universal constant, always the same and never changing. Next, consider Newton's laws, which state that velocities are never absolute, but always relative. For example, the train the second man is on may be going 40 kilometers per hour with respect to that first man. However, were it to come alongside another train that was going 30 kilometers per hour, it would only be going 10 kilometers per hour with respect to that second train. But wait, there's a problem. If Newton's laws are truly universal, why would light be an exception? Why would the speed of light stay constant? Einstein discovered a way for both of these ideas to coexist. However, it required stepping out of a mindset of Newton's. Consider the stick and the slinky. Newton believed that time traveled along an unflinching linear path, much like this stick, every event taking place along a straight line. Einstein discarded this notion and instead explained that time was like a slinky, being able to stretch and contract depending on velocity. The faster you go through space, the slower time runs for you relative to a bystander. He called this phenomenon time dilation. Massive objects like planets and stars, then, didn't pull bodies to them with an inexplicable force, but instead created dips in space-time that those smaller bodies would fall into. Then, approaching the center of the object, gravity increases and the things surrounding move faster through space. Thus, according to Einstein's hypothesis, time would run slower on, say, Earth's surface, for example, relative to its upper atmosphere. Einstein revolutionized modern physics when he first proposed time dilation in his theory of relativity, and his conclusions have been used as the launching point for many scientific studies to date. It just goes to show that sometimes you have to step out of the confines of what you thought you knew and approach things from a new angle.